Assalamualaikum and hello everyone. So today we will discuss tutorial chapter 6 from number 1 to number 16. Okay, so number 1 you have to define the following terms. So reversible reaction, maksudnya chemical reaction which takes place at forward and reverse directions. Okay, dia boleh forward dengan reverse. And then law of mass action ataupun equilibrium law is basically how you put this expression, but you have to define it in words. Okay, and then homogeneous equilibrium, homogeneous meaning same phase. Alright, so it's the whole sentence, bukannya bagi tahu same phase saja. Your reactants and products must be of the same phase. And heterogeneous equilibrium is achieved from a reversible reaction involving reactants and products of different phases. Okay, so B, you have to give two characteristics for dynamic equilibrium. Okay, when does your chemical reaction achieve dynamic equilibrium? It is when your concentrations of reactants and products remain unchanged. Okay, maksudnya dia dah jadi constant saja at equilibrium, and then the rate of forward reaction is equal to the rate of reverse reaction. Bukannya macam ni kan, ini maksudnya dia belum achieve dynamic equilibrium. Ini dia dah achieve. Alright, rate dia forward dengan reverse sama je, sama laju. Next is reaction quotient. Q is equal to your K. Alright, so second question is a question where it asks you to sketch a graph of variation of the concentration of A and B with time. So that means that this will be a concentration versus time graph, okay, until your system has achieved equilibrium. So explain the shape of your graph. So for this question, your graph, okay, you must follow the reaction given. A, the forward reaction is from A to B, so this is your reactant, this is your product. Right, so as your reaction goes, the concentration of A will deplete while the concentration of B will increase. Okay, so that means A will go down here, and then the concentration becomes constant, and then for B it will be formed. Okay, makin lama makin banyak increase. So and then dia akan jadi constant. Okay, so make sure to put your concentration against time, and then mark your time with a T1 symbol. Okay, time. Okay, so this will be the mark when your system has achieved equilibrium. Okay, after this time T1. Alright, so your explanation, okay, will be about the concentration of A and the concentration of B. Okay, so concentration of A will decrease with time. So maksudnya ni out tulis lah ya ayat dia. Concentration of A will decrease in time, with time. Concentration of B will increase with time. Betul tak? Dia makin lama makin banyak. And then the next point is after time T1, okay, what happens to the concentration of A and B? It will remain constant. Okay, this straight line, maksudnya constant. And then as the reaction proceeds, the rate of forward reaction, okay, yang awalnya lebih besar daripada reverse reaction, will decrease supaya dia jadi size macam ni. And then the rate of reverse reaction will increase, so dia pun akan sama besar. So maksudnya rate forward dengan rate reverse dia akan jadi sama. Alright, so when the rate of forward and reverse reaction becomes equal, therefore the concentration of A and concentration of B will remain constant. Okay, so those are the points for your explanation, okay, for this graph. Next, number 3, we will determine whether the following reactions are homogeneous or heterogeneous. So this is quite simple, right? You just have to look at the phases of your reactions. So since this is all in gas phase, that means it is homogeneous equilibrium. Okay, equilibrium. Spell it in full. So this is just a shortcut for me. And then second one is heterogeneous, because you have solid and gas phases, different phases. And then number 3 is also heterogeneous, right? Heterogeneous equilibrium, and this one will be heterogeneous as well. Okay, and then you want to write your equilibrium law, okay, for the above reactions in terms of Kc and Kp. Okay, so concentration and partial pressure. So for the first one, okay, you have all in gas phase, so that means you can write your Kc and Kp as follows. So make sure to write your product. Okay, for Kc it is concentration of POCl3 raised to the power of 2, because we have stoichiometry 2 here, over your reactants PCl3, okay, with 2 for your stoichiometry, and oxygen gas concentration. Okay, for Kp pula, it is your partial pressure of your gas. Okay, so you will just write this round bracket, and P besar maksudnya partial pressure of POCl3 to the power of 2. Okay, and this one pun sama, partial pressure and partial pressure. Okay, for this one pula, it is heterogeneous, so I think you all boleh buat. Okay, when you see solid or liquid, okay, you will not include them in your expressions. Alright, so maksudnya kita akan tulis CO2 over CO. Okay, so this is the answer. And then for number 3, you have aqueous, solid and aqueous, so we will not include the solid. Alright, so you can write Kc and Kp as well lah, macam biasa. Okay, and for number 4 pula, you will not include solid and liquid, so that means dengan solid yang ni, so maksudnya tinggal apa je, so you will be left with hydrogen gas lah, to the power of 4. Okay, so maksudnya awak punya Kc will be concentration of hydrogen to the power of 4. Okay, that's Kc. And then Kp, it will be partial pressure of H2 to the power of 4. Alright, so that is number 3. And then number 4, okay, at equilibrium there are 2.50 moles of SO2, 1.35 times 10 power of negative 5 moles of O2, and 8.7 moles of SO3 present in a 12-liter flask. Calculate the Kc equilibrium constant, okay, for this reaction here. Okay, so first you want to ask yourself, do I need to draw an ice table? Okay, so first you have to look at what the question is asking for. It is asking for equilibrium constant Kc. So your equilibrium constant Kc, maksudnya your expression will be at equilibrium lah, sebab ni K. Okay, so maksudnya kita keluarkan dulu Kc expression. Okay, so you will have SO3 and then to the power of 2 over SO2 to the power of 2 and oxygen gas. Right, so that is your expression. So from this expression, okay, you should know that this is at equilibrium, this is at equilibrium, and this is at equilibrium. Okay, because this is Kc, equilibrium constant. So now, can we find the concentration of each of this at equilibrium? Boleh kan, because we are already given the number of moles of each of the species at equilibrium. So what you're going to do is you are going to use the number of moles, okay, this divide by your volume, because concentration is mole over volume, okay, your molarity. Okay, so just divide for each of your species. So you will get this, this, and this, and then you will plug in your answer. Berapa? You will get 0.725 and then square, and then 0.2083 square, and O2 will be 1.125 times 10 to the power of -6. Okay, and then you will get your answer lah. Okay, so you have to show all your working, so make sure to show the working where you are looking for the concentration of each species. Okay, so tak payah draw ice table pun, sebab kita dah tahu the number of moles at equilibrium. Next, number 5, the partial pressures of PCl3, O2 and POCl3 at equilibrium are 80M respectively. So those are your partial pressures at equilibrium. Okay, so calculate the equilibrium constant Kp for the reaction here. So for this one pula, okay, first you are going to keluarkan the expression for Kp. Okay, so your expression will be POCl3, partial pressure 2, and then you have partial pressure of PCl3 2 and partial pressure of O2. Alright, so this is your Kp main expression, and then you know the partial pressure for each of the species, right? So what you're going to do is you are just going to plug in lah your values. Ini, dan ini. Nanti awak pun dapat the answer. So make sure Kc, Kp, you will not have any units, okay? Sebab dia adalah constant. Right, so simple je number 5. Next, number 6, the following reaction achieved equilibrium when the partial pressure of bromine gas is 0.60 atm. So that means that dia achieve equilibrium when the partial pressure is 0.6 atm. So from here dah ada dia punya chemical equation, and you are asked to determine the Kp. So since your FeBr3 and FeBr2 are in solid phases, so we will not include this in our Kp or Kc expression. Okay, so we just write down your Kp and Kc expressions, and then Kp expressions, okay, dari sini, and then masukkan je lah the partial pressure of bromine gas tu 0.6. So maksudnya 0.6 to the power of 1/2 atau square root, right? So then you can get lah your answer, which is 0.775. Alright, so next, okay, 6b, they ask you to derive Kp equals to Kc RT delta N. Okay, 1/2 lah awak punya delta N tu. So how are we going to derive this? So first you are going to keluarkan your Kp and Kc, like I already did here. So this will be your first equation, number 1, and this will be your second equation, number 2. Okay, so next you are going to assume bromine gas behaves ideally. So kalau behave ideally, maksudnya you are going to use PV equals to nRT. Okay, and then you will expand it where this is for specifically for Br2. Okay, so you want to keluarkan the expression where your pressure is in terms of concentration. So what you're going to do is you are going to rearrange your formula to get concentration. Okay, where number of mole is over volume. So this will be your concentration of Br2. Okay, so then you will get this. So once you get this will be your equation number 3. Okay, next what you're going to do is you are going to substitute equation 3 in 1. Okay, so you are going to put in PBr2 into this expression. Okay, So what will you get? You will get Kp equals to Br2 RT to the power of 1/2. Okay, so from here, since this is a bracket, okay, and this one will be for this and this, okay, for each of this, so we will expand it lah. Okay, ni maths kan, so you have Br2, this will be to the power of 1/2, and RT, just keep it together, okay, 1/2. So this will be now your equation number 4. Okay, so what you're going to do next is you want to equate Kp dengan Kc kan. So ini adalah Kp. So sekarang kita akan substitute. Again, substitute equation 2 in equation 4. Alright. So what is your equation 2 tadi? It is your Kc equals to concentration of Br2 to the power of 1/2. So it will become Kp equals to Kc RT to the power of 1/2. Right? Sebab awak dah gantikan lah, maksudnya yang ni, okay, dia actually awak punya Kc lah. Okay, here, right here. So that is how you derive this formula. Alright, so follow the steps and remember which is equation number 1, 2, 3 and 4. Okay, so next, number 7. So for number 7, okay, at 25 degrees Celsius, H2O liquid reached equilibrium according to the equation here. So calculate Kp and Kc for the reaction given the vapor pressure of water is 25 degrees Celsius is 23.8 torr. Alright, so kita nak cari Kp kan. So untuk cari Kp, kita kena keluarkan the expression lah for this reaction. So since you have liquid water here, so it is not going to be in your expression, so we only have H2O gas. So this will be the partial pressure of H2O, right? Okay, so from here you can actually already find your Kp, right? But we want our answer not in torr but in a DSI unit, ATM. Okay, because later we will be using this formula. So in this formula, your R, okay, is 0.08206. So that means your pressure must be in ATM. Alright, so what you're going to do is you are going to change this, okay, convert this into ATM. So times 1 ATM over 760 torr, and you will get 0.0313 ATM. Okay, so that means we already find our Kp, which is 0.0313. Okay, no unit tau. Alright, so next we want to find Kc, but we do not have any of the concentrations. We don't have the concentrations of water. So that means you are going to relate using this formula, since Kp equals to Kc RT delta N. Then to find Kc, it is actually awak find Kc, awak bawa turun yang ni pergi sini kan. So that means it is Kc equals to Kp. Okay, lepas tu RT delta N ni ada negatif sebab awak bawa turun. Okay, so ingat, bila this is the original formula, so when you change it up to find Kc, it is like this, you have negative delta N. So what you're going to do is you're just going to plug in your values. So you will get 0.0313 over your RT to the power of delta N. Okay, so your R will be 0.08206 liter ATM per mole per Kelvin times with 298.15 Kelvin. Okay, so your delta N, you have to tolak your product with reactant, so it will be negative 1 minus 1, so dia akan jadi 0, so dia macam tak adalah, dia akan jadi 1 kan, tak silap saya. So this will be 1.28 times 10 negative 3. Okay, so you get your Kc. Alright, okay, next number 8. So for number 8, okay, the question says 1.00 mole each. 1 mole each of carbon monoxide and chlorine gas are introduced into, so this is a hint, okay, that means that this is at non-equilibrium, or basically initial number of moles of your reactants. Okay, introduced into an evacuated 1.75 liter flask at 668 Kelvin. At equilibrium, okay, ini baru at equilibrium, total pressure of the gases mixture is 32.4 atm. So this is total pressure at equilibrium. Okay, so this is your total pressure at equilibrium. So calculate Kp. So apa-apa hal, you will always keluarkan dulu the expression for Kp. Okay, so this is the expression for Kp. Make sure that it is correct. Okay, check out your stoichiometry. Alright, and then you have the total pressure at equilibrium. Okay, if you are given this, you can actually use the ice table, okay, to find the partial pressure of each of these gases and then add them up together to get your total pressure. Okay, so what formula can we use? We can use PV equals to nRT since the mole of carbon monoxide and Cl2 is the same. So kalau ini adalah sama, okay, so ini sama kan, ini adalah constant, ini pun sama, ini pun sama, maksudnya awak punya pressure pun akan sama lah. Pressure of carbon monoxide will be equal to partial pressure of chlorine gas masa initial tu. Okay, so we can conclude that initial pressure of carbon monoxide is equal to the partial pressure of chlorine gas. Therefore, the formula to find these initial pressures of each of the gas will be nRT over V. Okay, just rearrange this formula. So, next, okay, in order to find the partial pressure of each of these gas, okay, maksudnya kita akan kena ada partial pressure of each of these gas at equilibrium lah. Okay, so to find that, you will need to get this part here, partial pressure of your gases at equilibrium. Okay, so we already have this, and then yang ni daripada sini, then you can get that. Okay, so what are you going to write? Okay, initial partial pressure berapa? Initial partial pressure will be 0, 0, and this will be, sorry. Initial partial pressure will be 31.32. Mana saya dapat? Saya dapat dari sini lah. So saya dapat daripada this formula to get your initial pressure of CO and pressure of Cl2. Okay, so it will be 31.32. Cari sendiri, kira So initially ada tu, so masa initial mestilah awak punya product tak form lagi. Okay, and then this will be, your reactant will minus X, your product will plus X. Okay, Kenapa X saja bukan 2X atau 3X? Because kat depan ni tak ada apa-apa, maksudnya 1. Okay. So, bring down 31.32 minus X. 31.32 minus X. And then this will be X. Okay. So, from here, now that we have the partial pressure at equilibrium for each of these, we can actually find the total pressure. We can actually find what is X using total pressure. Okay, so total pressure will be 31.32 minus X plus 31.32 minus X plus X equals to 32.4 ATM. Kan dah kena bagi kan. So you're going to find X. So your X will be 30.24 ATM. Alright. So now that we have X, we can actually find what is the partial pressure at equilibrium for CO and Cl2 as well as COCl2. Correct? So you're going to write that down if you are confused. P at equilibrium, your partial pressure for CO will be 31.32 minus your X will be 30.24. Okay, ini samalah juga dengan partial pressure of Cl2. Jadi it will be 1.08 ATM. Sorry, 1.08 ATM. Okay, and then your partial pressure for COCl2 will be 30.24 lah, sebab dia adalah X je kan. Here, right here. For this one, okay, X. So this is it. So can we write our Kp expression? Yes, we can. Okay, so just fill in your values here and then you will get your answer 25.9. Next, number 9. Ammonium hydrogen sulfide decomposes at 250 degrees Celsius according to this reaction. So this is your reaction and this is your Kp. Okay, so if 55 grams of solid NH4HS is placed in a sealed 5-liter container, what is the partial pressure of NH3 and H2S at equilibrium? So this is kind of a trick. Okay, so if we look at our Kp, okay, your Kp here, this value is not determined by your solid NH4HS. Alright, so that means when we draw our ice table juga, this will not be there. Okay, this will not be in our ice table because it is solid. Okay, so itu adalah trik sahaja. That means since it's solid, you will just put dash here sampai kat bawah. Okay, tiga-tiga tu. So part sini boleh buat macam biasa. Okay, so your product initially will be 0 and 0 ATM, dia punya partial pressure, and then your delta P, okay, will be plus X, okay, sebab tak ada apa-apa kat sini, and this will also be plus X sebab awak buat product. Okay, so your P partial pressure at equilibrium will be X and X. Alright, so from here we can actually find our X because we are already given the Kp, right? So kalau letak balik kat sini, it will be X and X, right? Only. So X square, true. So X is equal to square root of 0.110. What will X be? X will be 0.33 ATM. So that means what is the partial pressure of NH3 and H2S at equilibrium? Yang ini, NH3 at equilibrium, it is X. H2S pun, it is X. So that means the partial pressure of NH3 is equal to the partial pressure of H2S, because both are X. So what is your X just now? It is 0.33 atm. Okay. Alright. Next, number 10 is also like just now. Okay. But here we got a quadratic equation. So just do this slowly. So bromine gas is allowed to reach equilibrium at this temperature according to this equation. So your Kc is given, alright, and your initial concentrations of Br2 and Br are also given. Okay, so itu adalah initial concentration. Okay, bukan at equilibrium. So calculate the concentrations of this species at equilibrium. So kita nak tahu concentration at equilibrium. So maksudnya terang-teranglah kita kena guna ice table. Okay, so from your Kc, you can keluarkan your expression, okay, and just equate it. So for your future use, alright. So we are going to fill in the initial concentration. Your initial concentration is already given, so directly just masukkan je 0.063 for Br2. This is 0.063 molar. And 2Br is 0.012 molar. Okay. So, hati-hati kat sini. Awak tengok awak punya chemical equation here. Your stoichiometry for Br is 2. So, that means at this part here, you must put 2 plus 2x. Okay. So, your reactant yang ni will be minus x. Okay. So now about to turun 0.063 minus x and 0.012 plus 2x. Alright, so now that we have the concentration at equilibrium punya expression, we can actually find the what is x lah. Okay, using Kc. Okay, sebab yang ni kan, ini adalah concentration at equilibrium. Maksudnya, it is actually this lah. So, samakan je. Alright? So, you're going to write down what it is. Equals to Br2 square kan? So, 0.063 minus x square over Br2 no square. So, 0.012 plus 2x. Okay, so dari sini awak boleh buatlah quadratic expression awak. What should you do? You are going to expand this. Okay, so samakan this whole equation. So you have 0. What I'm going to do is I'm going to take this and this and copy. So paste. Alright. So you have this. So what you're going to do is you are going to expand this. You expand this and then awak samakan lah the terms yang x square, yang x dengan yang constant, tak ada x. Okay, so what you will get is you will get 4x square plus 0.049x plus 7.47x bukan x times 10 to the power of negative 5 equals to 0. Alright, so use your calculator and find what your x values are. So your x1 will be minus 1.78 times 10 negative 3, and the other one will be minus 0.01050. Okay, so two negative values. you're going to take the smaller value. Okay, so you are going to use this one. So this one will be ignored. Okay, so you're going to use this one here. Okay, so apa kita akan guna X tu untuk cari apa? Kita nak cari apa tadi? Nak cari the concentration of this species kan? So concentration at equilibrium of this species. So maksudnya awak akan masukkan X dekat sini lah untuk cari the partial pressure at equilibrium for BR2 dengan 2BR. Okay, so maksudnya cari je lah concentration of BR2 at equilibrium will be 0.063 minus your X, 1.7, negative 1.78 times 10, negative 3. So awak akan dapat jawapan awak. And also for BR at equilibrium, it will be 0.012 plus 2x. Okay, so dapatlah jawapan awak. Okay, so part sini dipanjang sikit pasal quadratic equation ni lah. Okay, right, next question. Number 11. Define the degree of dissociation. You can find this in your notes. B. If 0.024 moles of N2O4 is allowed to reach equilibrium with NO2 in a 0.372 liter flask at 25 degrees Celsius, the Kc given is 4.61 times 10 negative 3. So calculate the degree of dissociation alpha of N2O4. Okay, so first of all, we are going to look at degree of dissociation. What is the formula? The formula is when you let degree of dissociation to be alpha equals to X, okay, your dissociation over the initial concentration lah. In this case, it is N2O4 sebab kita nak cari degree of dissociation for N2O4 kan. So that means we need to find our X and we need to have our initial concentration. So in your question, you are already given the number of moles for N2O4 at initial. Okay, so this is already the number of moles. So since to find concentration, you will need to use the formula molarity equals to number of mole over volume. That means you just have to divide your mole with volume. Alright, so from here you can actually find your concentration of N2O4 at initially. What was it initially? So 0.024, okay, mole divide by 0.372 liter. Okay, so you will get 0.0645 molar. Okay, so maksudnya what we are left with is X lah yang kita nak kena cari. Ini dah ada 0.0645 molar. So how are we going to find X? We are going to draw our ice table. Okay, so since you already have the initial concentration of N2O4 at initial, okay, yang ni will be 0 sebab dia adalah product, dia tak form lagi. And then we can find the initial concentration, okay, where you have it in terms of X. So masukkan 0.0645 and this will be 0. Okay, and then this will be minus X and this will be plus 2X. Betul? 2 because you have stoichiometry 2 here, and plus because you are going to form the products. So this will be 0.0645 minus X and this will be 2X. Okay, now that we have this, we are going to use Kc expression to find what is X. Okay, so what is your Kc expression? So your Kc expression just now was, oh saya tak tulis. Kc equals to NO2, your product, square over concentration of N2O4. Yes. Okay. Alright. So, masukkan je values yang ini. Here. So, NO2 will be 2x square and 0.0645 minus x. Sama dengan apa? Awak punya Kc. Your Kc is here. 4.61 times 10 negative 3. 4.61 times 10 negative 3. Okay. So, you are going to find what is x. So, you will get your quadratic equation juga. Okay. Try lah. Expand this. Okay. Then you will get the quadratic equation 4x squared plus 4.61 times 10 negative 3 minus 2.973 times 10 negative 4 equals to 0. Okay, so find your x. You will get two values. Okay, so ini saya tak naklah bagi tahu. You will get satu positive and satu negative. So in this case, you will take the positive value. Okay, neglect the negative value, and then you can, once you found your x, you can put that in this expression to find the degree of dissociation of N2O4. So this will be your x tadi. Okay, and then this one will be this one here. Awak masukkan je. And you will get 0.12. Boleh? Okay. Number 12. At 430 degrees Celsius, the equilibrium constant Kc for reversible reaction is 4.18 times 10 negative 13. Okay. So if 0.040 mole of Hi, this mole of H2 and this mole of I2 are initially, maksudnya this is initial punya information, or non-equilibrium, placed in 2 liter volume container, is the system at equilibrium? So, when the question asks you, is the system at equilibrium, you need to know that your system is at equilibrium when QC is equals to KC atau QP is equals to KP. Okay, so macam mana nak tahu whether awak punya system is at equilibrium or not? You will have to compare your QC with KC. Okay, so QC is your reaction quotient, where your system is at non-equilibrium, belum equilibrium. KC bila dah equilibrium. Okay, so kita kena carilah QC kita. Maksudnya kita akan masukkan these values, okay, dekat dalam awak punya QC. So if your QC is more than KC, is larger than KC, that means you have more product than reactant, because okay, your QC will look like this, concentration of product over reactant. Okay, so kalau dia value dia besar, QC ni, maksudnya awak punya produk banyak lah. Okay, so kalau value dia kecil, maksudnya produk awak sikit, maksudnya awak ada lebih reactant. Alright, so you're going to find QC. What is QC? Expression dia sama je macam KC, just that it is at non-equilibrium lah. So you're going to write Hi square over H2 times I2. Okay, so from here you're just going to put in your initial concentrations. Okay, jangan careless and masukkan ini straight into your expression, because this is the number of moles. Okay, so this is your volume, so make sure to divide each of this with 2 liter to get your concentration. So masukkan concentration and then you will get your QC. Okay, saya tak tunjuk working, awak kena tunjuk working. So Okay, sebab ada markah nanti. So you will find that your QC will be 5.33. Okay, so your QC is 5.33 while your KC is this. Okay, so siapa lebih besar? Your QC is larger than KC. Okay, so what does that mean? What does that mean? It means that your system, the system, is not at equilibrium. Alright? Thus, the reaction will shift where if it is not in the equilibrium. Ini maksudnya awak punya produk ke reactant lebih banyak. Awak punya produk more than reactant, kan? So, untuk kurangkan produk tu supaya awak capai equilibrium macam mana? Awak akan shift to, nak kurangkan produk, awak kena shift to the left. Okay? So, shift to the left maksudnya your reaction will shift, reaction shifts to the left in order to achieve a chemical equilibrium. Alright? Okay, so soalan ni pun sama je, just that beza dia this is KP. Okay, so carilah awak punya QP tu, dia besar ke atau dia kecil daripada awak punya KP. Okay, lepas tu awak kena make a conclusion whether more product or reactant is formed. Okay. Next, number 14, state Le Chatelier's principle. Okay, yang ni saya suka Le Chatelier. Principle. Okay, this one you can get in your notes. Alright, so it states that when a chemical system is disturbed, it will retain its equilibrium by undergoing a net reaction that reduces the effect of the disturbance. So, B, maksudnya bila awak punya reaction kena disturb, contoh temperature naik, then awak punya system akan try untuk kurangkan awak punya temperature. So, untuk kurangkan tu dia kena shift left ke atau right. Okay, shift ke mana? So, this is our reaction and it is an endothermic reaction. So, kalau endothermic reaction maksudnya awak punya reactant kena absorb heat in order to produce the product. So, where is your heat? Is it on the left or on your right? It will be on your left. Okay? Because heat is needed in order to produce your products. Alright? So, by using Le Chatelier's principle, explain the shift in equilibrium position, maksudnya shift to right or shift to left, if any, of the reaction, if, number 1, the concentration of hydrogen gas is decreased. So, hydrogen gas here, kalau your hydrogen gas is decreased, what will your system do? It will try to increase the concentration balik. Okay, untuk maintain the equilibrium. So, what are we going to do? Kita akan shift ke kanan ke kiri. Untuk buat lebih banyak H2, kita akan shift ke kanan. Okay, so the answer will be right. So, when the concentration of hydrogen gas is decreased, the equilibrium will re-establish to increase the concentration of hydrogen gas so that the equilibrium moves to the right. Next, if the temperature is lowered, so kalau temperature is lowered, then your system will try to increase the temperature again. So, which side, okay, will produce heat? Kita akan produce heat when we shift to the left. Okay, awak punya heat on your left. So, bila temperature is lowered, your system will try to increase your temperature again by shifting to the left to produce more heat, since the forward reaction is endothermic reaction. Okay. Okay. Next, catalyst. If catalyst is added, will there be any change? No, okay, no change, because the function of catalyst is to make reaction faster. Okay, dia tidak akan kacau the rate of your it will not affect your equilibrium position. Okay, C2H6 is removed from the system. Maksudnya ini akan remove. So bila this will be removed, your system will try to make more of this. So that means your equilibrium will shift to the left. Okay, sebab nak buat dia lagi banyak. So it will shift to the left to re-establish equilibrium and produce more C2H6. So the equilibrium will be re-established lah. Okay. Next, volume of container is increased. So if the volume of container is increased, what happens to the pressure of the vessel? So kalau container tu makin besar, maksudnya pressure akan decrease. So if pressure is decreased, your system will try to increase the pressure again. So how do we increase pressure? Okay, when we are talking about pressure, we will look at the number of moles. Okay, on your left and right. So on your right you have 1 mole. On your left you have 1 mole. On your right you have 2 moles. Okay, so in order to increase pressure, balik, okay, your system wants to increase pressure, you are going to shift to the side with more number of moles. That means your equilibrium will shift to the right, because kat sini ada 2 moles. Bila kita ada banyak lagi mole kan dalam kita punya container, then our pressure in the vessel will increase. Correct? So the sentence will be right because when the volume of container is increased, it lowers the pressure of the vessel and the equilibrium will be re-established to increase pressure. So the equilibrium moves to the right, where the side of with the more number of moles. Okay. Next, pressure is increased. So kalau pressure is increased pula, then your system will try to decrease lah the pressure. How? Maksudnya terbalik lah macam tadi. Kita akan shift to the side with lesser number of moles, which is to the left. Alright? Untuk re-establish the equilibrium. Okay. Next, an inert gas is added at constant pressure. So, inert gas ni, it will not react with your existing gas. Okay. So, bila awak add this at constant pressure, okay, this is the hint. Maksudnya, there will be a change in volume. Okay, terbalik. Kalau constant volume pula, there will be a change in total pressure. Okay, so kita tengok yang first ni, constant pressure. Kalau at constant pressure, maksudnya, awak akan change the volume of the container. Okay, so what will happen to the volume of the mixture? Okay, kalau constant pressure, awak add more gas, then the volume of your container will increase, kan? Volume increase. So kalau volume increase, that means what will happen? The partial pressure of your gases will stay the same. The partial pressure of your reacting gases will decrease, kan? Sebab dia ada lebih banyak space. So each of the gas ni, yang ni, dia punya partial pressure akan kurang. Okay, will decrease. So the overall pressure of the equilibrium mixture will also decrease. Alright, sebab tu awak punya pressure remains constant. So the reaction will proceed in the direction that will produce more number of moles to increase the pressure balik. Alright, so that means it will shift to the right. Alright, so that will re-establish the equilibrium of your system. Next, bila inert gas is added at constant volume. So constant volume means that awak punya bekas tu tak berubah dia punya volume. Therefore, there will be a change in total pressure when you add in more gases. Okay, So for this one, when you add inert gas at constant volume, what will happen to the partial pressure of your substances involved in the reaction? Maksudnya awak punya ni, these gases, what will happen? Since your total pressure can change, that means your partial pressure of each of these gases will not change. Betul tak? So kalau tak ada changes, that means okay, adding inert gas at constant volume will give no change to the shift in equilibrium position. Okay, because adding inert gas at constant volume does not change the partial pressure of the substance involved in the reaction. So kita tak payahlah nak tinggikan atau kurangkan partial pressure, because our partial pressure of each of these gases dia tak berubah, alright, at constant volume, sebab our total pressure will change. Okay. Okay, alright. Next, number 15. So number 15. So the Haber process is represented by this equation with this delta H exothermic reaction. So its feasibility depends on choosing conditions under which nitrogen and hydrogen react rapidly to give high yield of ammonia. So at 25 degrees Celsius and atmospheric pressure, the position of the equilibrium favors the formation of NH3. So maksudnya at 25 degrees Celsius, okay, and atmospheric pressure, position of equilibrium will favor the formation of ammonia. Okay, maksudnya awak punya equilibrium shift to the right. So based on Le Chatelier's principle, explain how the product could be increased. Okay, so for this question, kita kena take account of temperature, pressure, volume, concentration of your reactant and product, and ini. Okay, untuk naikkan kita punya yield of product. So what can we do? So first, we need to notice that this is an exothermic reaction. That means that this forward reaction will release heat. Okay, so that means that your heat will be on the left or right side. It will be on your right side lah, because you will produce heat. Okay, so when you produce heat, kan, if we talk about temperature, okay, how are we going to produce more NH3? Macam mana kita nak kita punya reaction go to the right? You are going to decrease temperature. Okay, why do we want to decrease temperature? Because when you decrease your temperature, okay, for this exothermic reaction, then your system will try to increase the temperature again. So in order to increase the temperature, your equilibrium will shift to the right, and therefore when it shifts to the right, you will produce more heat and also your product. Okay, so our punya ayat for this point is decrease temperature, because the reaction is exothermic. So decreasing the temperature will shift the equilibrium to the right. Okay, next, how about pressure or volume? So pressure and volume ni it is inversely proportional, kan? So maksudnya, let's say if we use the point volume, maksudnya kita akan decrease the volume. Kalau kita decrease the volume, then the pressure will increase. Betul? So either of these 2 points, okay, addition of pressure and decreasing the volume will shift the equilibrium to where? Kita akan tengok the number of moles, kan? So this will be 4 moles. This will be 2 moles. So kalau kita increase pressure, okay, senang tengok pressure lah. Increase pressure, then your system will try to decrease your pressure. How? By shifting towards the side with fewer number of moles. Okay, so kita actually kena tengok lah the number of moles of our reaction ni. So kat sini lebih kecil number of moles, maksudnya kita nak our reaction to go to the right with the fewer number of moles. That means we have to increase pressure or reduce your volume. Okay, so when you do this, then your equilibrium will shift to the right to the fewer number of moles. Okay, so the reaction will shift to the right, so the amount of product will increase. Okay, next we can talk about concentration, right? So in order for our reaction to go to the right, okay, maksudnya kita kena ada kat sini banyak supaya dia nak kurangkan. Betul? So that means you can increase or add the concentration of N2 and H2. Alright? Or H2. So addition of your reactant will shift the equilibrium to the right. Okay? So you produce more products. You can also remove your NH3. So if you remove your NH3, that means your system will try to make more of NH3. That means your equilibrium will shift to the right and actually produce even more NH3. Okay?